Hi, I'm Dante Malagrino. I'm the founder and chief product officer at Embrane. Embrane was founded in 2009, and we've had several conversations with you guys, and I'm very glad to be here and share an update on where the company is at.
Tom Nacella, chief strategy officer with Embrane, and I run the technical operations part of Embrane.
Colin McNamara, chief cloud architect and director of the cloud practice at NexusIS, a Dimension data company. I'm an OpenStack active technical contributor and ambassador, and you can find me at Colin McNamara on CalvinMcNamara.com.
Caleb Leadership. I work for VAR, and you can find me on Twitter at VCadage.
Robert Novak. I'm a deep generalist sysadmin. I blog at rsts11.com and tweet as Gallifrey.
Steve Rochagrosa, Senior Network Engineer for Retail, on Twitter at Stephen086, and blogging at ccieurnode.net.
Ethan Banks, Senior Network Architect for CareNection, a telemed company, and co-host of the Packet Pushes podcast. I tweet at ECBanks and blog at ethancbanks.com.
I'm Matt Oswalt, stuck on the fence between network and software. And I blog at keylingclassless.net.
My name is Edward Henry. I'm a senior network engineer for a regional service provider in the state of Connecticut, and you can find me online on Twitter at networknerd with a 3.
I'm Bob McCouch, CCIE, independent network consultant. You can find me on my blog at herdingpackets.net and on Twitter as at Bob McCouch.
Pete Welcher, longtime CCIE. I do route switch data center. With a Cisco Gold partner that's services oriented, NetCraftsman, and that's where you can find my blogs, netcraftsman.net.
I'm William Bell. I also work at Chesapeake NetCraftsman. I am a CCIE and a Cisco Support Community Designated VIP, and I blog at ucgorilla.com.
Let me start by framing why we do what we do, right? So first of all, there are a few trends, as we all know, about building next generation networks in the data center, right? You look at the software-defined data center from VMware, you look at the ACI, the application center infrastructure from Cisco, various other flavors and initiatives around things that are happening in networking. There's clearly Open Daylight that kind of plugs into some of these activities. There's a lot of stuff going on. But when you look at all of these next-gen architectures, there are some traits that I think are very important, especially from customer adoption perspective, right? I think there is a lot of need for, I think people looking at these next generation are looking at these especially coming from the perspective of wanting more automation. If anything, when you scrap all the marketing off, I think probably the most descriptive technical word that I find to describe what people are looking for is automation, right? So automation in order to simplify the management of complex infrastructure and accelerate the delivery times of services in general in IT and then specifically networking. So automation is really driving a lot of that. Automation through policy management also is quite key, quite critical. Obviously, between Cisco and the ACI, the OpFlex model, there's a lot of conversation now around who's going to own the policy model and what does that mean. So that's also very important. Another element that I think is very important is there is a resurgence of multi-tenancy, right? Multi-tenancy tended to be very much a service provider concept it's been and it is for a service provider construct, but I see a lot more demand for multi-tenancy also from an enterprise perspective. So when we have conversation with enterprise customers, now they want to get more isolation. That's a word that sounds more appealing to the enterprises when they talk about multi-tenancy, but isolation of applications, isolation of departments. Now, the interesting point about multi-tenancy is that people now want to do multi-tenancy without necessarily sharing common, infrastructure, without sharing devices. So they want to have multi-tenancy with dedicated infrastructure somehow. Now, we'll talk more about what that means, but that's my point when I talk about dedicated tenancy. And if you talk about multi-tenancy in terms of one instance of everything on a per application basis, very quickly there's a scale dimension that plays in, especially in the context of an enterprise. So dedicated tenancy at scale seems to be another driver underlying a lot of these next generation architectures. And then it goes without saying, agility, rapid deployment, these are all buzzwords that we hear quite a bit. Now, when you look at these requirements, one point that's very that I want to make, when you look at these requirements, the hardware model for layer 4 through 7 doesn't seem to be really adequate anymore, right? When you think about these hardware devices shared across multiple tenants or multiple applications, constrained by the form factor being a hardware form factor, they don't seem to quite fit the requirements that I've listed in the first three bullets up there. Virtual appliances, on the other hand, look much more promising. Yeah? The idea of being able to spin up instances on a per tenant basis, to be able to do everything in software, to build automation around it, that seems to be a lot more compelling. But unfortunately, if you look at people that have tried to do a lot of these things with virtual appliances come with a fairly significant management tax, if you want. So it's very complicated with, to manage the whole process of what we call, actually, I think it got reformatted a little bit, but it's very complicated to manage what we call the life cycle management, to automate the life cycle management of these appliances, of these virtual network services. Now, what does it mean? What is life cycle management? So, to describe, the best way to describe life cycle management is to look at the list of things that you would have to do if you want to run virtual in your infrastructure. Right? Think about, you want to run virtual firewalls for your data center. What does that mean? Well, it means that you need to figure out how to instantiate these virtual appliances. You need to figure out how to deal with licensing. Licensing is a very complicated, usually very, very problematic thing to deal with in the context of virtual solutions. You have to deal with basic configuration of the management IP address. Now, as simple and as intuitive as that may sound, configuring a management IP address oftentimes is not something that is available through API calls, and it's something that usually requires console access or special access to the device. So there are a lot of things, and you can go down the list here, all the way down to things like upgrades. You deploy a virtual solution, you have hundreds or thousands of these virtual appliances. Now all of a sudden you have to upgrade the software on these appliances. You cannot really think about doing that on an appliance by appliance basis, right? You clearly need a mechanism to control and manage these proliferation of instances, proliferation of virtual instances in a consistent way. So all of these, and more effectively, is really what we consider life cycle management of virtual solutions. Now the question usually at this point is, okay, but why is this different? Why is this different than what we need to do for physical appliances? Well, in a physical world, things tend to be easier for a couple of reasons. Number one, because you don't really need to worry about instantiating a physical appliance. I mean, as long as you know which rack you're going to have to put it, and as long as you know what kind of network connectivity you require from the appliance, you plug the power, you configure a management IP address, and you're pretty much done for the following few years of the existence and life cycle of that appliance. You don't really move around physical boxes in your data centers, right? These things tend not to fail very often. So it's a much more static device and function that you're dealing with if it's a physical appliance. In a virtual world, things are completely different, right? If you have a virtual appliance and you have to install this virtual appliance, the first thing you're going to have to figure out is, which server am I going to run it on? Do I have enough resources, memory, CPU, and network connectivity on that server? What else is running on that server? Do I have the network connectivity coming to that server so that that appliance can communicate with the rest of the infrastructure the way it's supposed to be? So there are a lot of things that you have to figure out, even just to understand where to go and locate that appliance. Then you have to install it, which is a software process, right? Which is obviously, it's more complicated and more prone to risk and failure. So if you just look at step number one, it's a fairly complicated step. Now, can you do these things without Embrane today? Sure, you can, because you can certainly go and maybe you're using vCenter, and we can talk about whether or not people want to use vCenter for these things, but you can use vCenter, you can use a combination of custom-made tools, you can use the available GUI and CLIs, you can use manual processes, you can write scripts. People do these things, right? The problem is that it's a very complicated, time-consuming process, and of course, because there's quite a significant human intervention involved, tends to be more prone to risk, right? So prone to failure, sorry. So you're going to have to be careful. Now, everything I'm describing here applies on a single appliance. Now, think about what we said before. If I have a very high-scale multi-tenant environment, and I want to have one appliance or a set of appliances per each application, which is what you hear from many vendors in the industry right now, the problem compounds, right? Because now I have to deal with these on hundreds or thousands of instances, right? And think about something very simple. You have maybe 50 or 100 appliances all running on a single physical server. The server fails. Now, that's a scary moment if you don't know what to do, because probably if you're doing these on your own, you probably have a spreadsheet or something where you're keeping track of all the appliances that are running on that server. You're going to have to go and relocate those appliances somewhere else, figure out where you have sufficient resources. You may not have an identical server, so you may have to spread out these services across multiple. It's a very complicated process. Not to mention that the services we're talking about, firewall, load balancing, VPN, and so on, they tend to be networking services. So they are usually managed by the networking team. And the networking team is not supposed to be expert in compute or virtualization or software management or software install and all that kind of stuff. So we're also talking of a problem that needs to be solved and addressed by a team that doesn't really have all the skills that is assumed behind all of these tasks. So that's the complexity, all right? So I probably spent too much time talking about it, but that's the complexity we want to address. Now, what do we do at Embrane? The Embrane product is very simple. It's composed of two elements. One is the Elastic Services Manager, or ESM. We all need to have our own three-letter acronyms. Actually, it looks like we're moving to four-letter acronyms now, if you've seen the EPIC. But we all have to have the three-letter acronyms. But the ESM, the Elastic Services Manager, is effectively what we call the lifecycle management tool here. Now, the ESM controls a pool of instances of network services that can be either Embrane own. We have our own services. We have our own load balancer, our own firewall. It's actually the firewall and the load balancer, but the firewall also does VPN, NAT, basic routing function, and the load balancer also supports SSL offload. But also, we have now partnered with companies like Cisco for the virtual ASA, SourceFire for the 3D sensors, and the announcement of this morning was about support for the Citrix VPX, the NetScaler 1000V, which is the OEM version by Cisco, as well as the A10 virtual appliance for server load balancing. So the idea is that a lot of the issues I was talking about before, a lot of the tasks I was talking about before, we can do not only for our own services, but we can also do now for third-party appliances. So for those customers that want to preserve, the feature set and the user interface and whatever they love of those third parties, they can keep using that, but we enable them to move to a virtual form factor because we make it easy for them to deploy virtual, and especially to deploy virtual on a large scale in a manageable fashion. Okay? Now, as you can imagine, we've been saying these for quite a few years, even from the first time we got together a while ago, but we keep saying it, everything is API driven, right? Because in this world of automation, in this world of integration with orchestration tools, cloud management tool, OpenStack, of course, you want to have your product entirely exposed through API. So everything is API driven. There are RESTful APIs, both to drive the ESM as well as each one of our services. Of course, when it comes to our partners, it depends on what level of API support they have, but clearly the industry is moving in this direction. So for those that are not there yet, they will be there at some point because it's the only way to survive in the market. But it's also true that on the other hand, you want to have user-friendly tools that you can give to the network operations team or to the folks that are evaluating your product so that they can get quick access to it. So you will see very, very soon the demo. The demo is going to use our GUI, our user interface. That's entirely an API front end. So everything you see there, it's going to API calls on the back end. And we used to say that if it's not, if it's not in the API, it's not in the product. If it's not exposed by the API, it's not a feature of the product. You probably hear these from every other vendor that comes to talk to you, but I think it's a very important point that needs emphasizing. All right. And again, the key here is to have a centralized point of management for the life cycle of all of these appliances. Can be hundreds or thousands of appliances under control of one or multiple ESMs, depending on the design that the customer chooses to have. And Tom will go a little bit more into the features of what that does. Now, this is another very important point, right? How do we design into the existing network infrastructure? So how do you design Embrane into existing network solution? And in general, probably, how do you look at deploying virtual network services in data centers today? Now, before I go and talk about these, I want to share with you a little bit of an anecdote. A couple of weeks ago, I was talking in front of a customer audience, all network people, right? So network architects, network operators. And I asked the general question, said, so how many of you are looking at a virtual strategy for network services? I got a couple of people pretty much angry at me. You know, they were very animated in their response because they said, oh, absolutely, I'm never going to use that because I don't know what happens then if I put my firewall through vCenter, all of a sudden it's going into the systems team and I've lost visibility, and what happens to the compliance? And you know, that made me realize that there was a fundamental assumption that that person was making that's not necessarily true. The assumption he was making is that if it's virtual, it belongs to the compute virtual environment. So in his mind, that was represented by vCenter. But in other words, if it's virtual for him, it was something that was shared with the compute, with the application workloads, which is obviously possible, but it's not necessarily the way it should be. And as a matter of fact, if you think about it from simplicity of troubleshooting, compliance, deployment, management, it's probably better to keep things separate, right? Because they're separate now, they're under separate teams, they're different kind of workloads. There's some benefit in maintaining the things slightly separate. Now, you can merge if you want, but you shouldn't be forced to merge, right? You shouldn't tell the network guy that all of a sudden that firewall disappears from the rack where he's used to look and point to the firewall and ends up who knows where, and nobody knows what's happening to that anymore, right? So the key point I want to make here is that, you know, we come from the networking world, right? So we were at Cisco before, so we've spent a lot of time working on networking. When we look at this virtual world, what we wanted to do was, the first thing we wanted to do was to be able to replicate as much as possible the existing operational model. The fact that you want to virtualize the firewall doesn't mean, has nothing to do with the fact that you are virtualizing or not the compute environment. There are benefits to virtualizing the load balancer, the firewall, any networking function, completely independent of what you're doing at the compute layer. In fact, this is another misconception that people often have. Oh, you know, I'm not really in virtual yet. I'm running a whole bunch of physical workloads, so I don't see why I need to virtualize my function XYZ. Well, it's a completely different assessment, right? It doesn't, not only because you have virtual machines in the compute world, it means that you have to absolutely virtualize the firewall and vice versa. Anyway, from our point of view, we support these three different deployment models. The first one is what we call the dedicated centralized. So if customers want to have all these network services deployed in a place where they know where they are, they know what they do, and they can have full control on that, they can take a few servers, dedicate those servers, and you will see that in the demo, dedicate those servers to run network services, and you know, that's it. So from that point on, these virtual network services are all going to run on this pool of compute resources. As a matter of fact, this is a model that kind of exists already, if you want, right? You look at the NetScaler SDX, you look at Cisco with the Nexus 1110. There are some vendors that are beginning to ship, you know, sort of general purpose or close to general purpose hardware that's supposed to run virtual network functions. And I think it's a model that will become more and more dominant over time. Now, a slight variation of that. Now, the benefit of this model is that it's extremely consistent with the physical model, but it gives you all the flexibility of the virtual. So, from a topological perspective, I mean, obviously, I'm not sure you understand this is a logical diagram. There's probably another switch there, but the point is, from a logical perspective, the virtual firewall that you end up deploying on this pool of compute is no different than the physical firewall or a context, a partition of the physical firewall that you had in the physical world before. But now you have the benefit of dealing with a true virtual entity. So you can spin it up and down when you want it, you can size it the dimension you want it, you can do all the nice things that I was talking about before. Now, a slight variation of this model is what we call the dedicated localized. I mean, frankly speaking, this is a technical audience. From a technical standpoint, it doesn't really make any difference, but it's important to point it out because in many cases, people like to partition their infrastructure in racks, pods, these are the most common names. So you may say, well, you may have a pool of compute, a subset of the compute in each one of these racks, pods, probably more technically accurate layer 3 domains can be allocated to run certain network services. But again, from an overall perspective, they're very similar in terms of deployment models. And then you have the third model, which is the model where you share compute resources, right? Now, the interesting point of this model is that if you're sharing resources, you're going to have to interoperate with whatever is managing that pool of compute. So if it's a VMware environment, we interoperate with vCenter. If it's an OpenStack environment, it's about working with Nova, for example. And right now, I think these are probably the two predominant compute, virtual machine lifecycle management tools that we can think about, right? But again, this is another model. Now, this model is a model that some people tend to prefer because there's a perceived sense of efficiency in the utilization of resources. But we think that the dedicated model tends to offer more simplicity from an operational standpoint. Any questions so far? All right. Now, as I said before, no matter which one you use, and certainly especially if you use the dedicated, there's no assumption on what portion of the compute infrastructure gets served. So we support physical and virtual compute infrastructure. I mean, a firewall is a firewall, and if you virtualize that firewall, the firewall is still going to secure a piece of the infrastructure, whether that is physical or virtual. So the beauty of this model is that by staying independent of what happens at the compute layer, it's independent also of the form factor of the compute layer. And because, no matter how much we love and think and talk about virtualization, data centers continue to be hybrid and probably will be hybrid for quite a while, it's important to have a solution, we think it's important to have a solution that is consistent across the physical and virtual world. Okay? And last one, for those of you who like the architectural diagram, this is actually Marco's favorite. But it's important, if you want to place as, if you say, okay, but I'm still confused from an architectural standpoint, where does Embrane really fit? And think about, in general, think about what's going on in the data center, right? We start from a pool of raw, sometimes we call them physical resources, unprovisioned resources, and then in different areas, and I'm taking the four major ones I can think of, compute, storage, network, and network services. In each one of these areas, there are lifecycle management tools, think of vCenter, for example, in compute, that allow you to provision and abstract those resources so that they can be utilized by higher level orchestration or policy management tools. And so there are, probably storage is a little bit it's not as mature as compute. If you look at what's happening in the network space, the AP controller from Cisco, in my view, is among other things, it performs the lifecycle management functionality of abstracting physical connectivity from the switches into logical connectivity. To some extent, you look at NSX from VMware, kind of a similar thing for the layer 2 functionality, if you want. I mean, there are probably, I would say, probably the old OpenFlow, Open Daylight kind of does the same thing, right? So fits into this, but anything that is the new controller-centric architecture tend to do the lifecycle management of network connectivity. Now, what we do is the same thing at layer 4 through 7. We abstract a pool of general purpose x86 compute resources into logical services. All right?